Okay, so today what we are going to do is we are going to continue our series of solving the problems from A to integration B, right? Uh, yeah, like today we are going to solve in the live video as well as unprepared for today. Like I'm going to see how we can deal with the integrals. Like if I was prepared, I would just go with whatever works, right? But today, since I don't know what it works, we will see how what's my strategy. Everyone's might be different, but yeah, how we can go to the solution from the very beginning. Yeah, I think some beginners will be helpful. I mean, helped by that, it will be helpful for beginners. Yeah, so let's see how do we do that. So I have over here the problems from 2014 American Integration B, right? So let me also check if this live is going well first. Okay, wait. So there's this live video. Let me see if it's working or not in the live section. Mm. Is it not working well? Why is the live video not working well on my phone? Oh, is it working in anyone's? Let me see. It's not working in mine. What might be the problem? Okay. Yeah, it seems like it's working. Oh. Oh yeah, there. Yes. We can compete up
Yeah,
good.
it seems like it's working.
Okay, yeah. Shall we start? Are you guys ready? I can see your chat and yeah. I will
Seems like it's
just
working.
check your chat from my device, mobile device, and yeah, we can solve problems over here. Are you ready, guys, to solve the problems? You are also practicing for the competition. Yeah. Let us begin. Let us begin. Yes. Okay. So yeah. I think the first few problems will be easier. Okay, so the first one is integral from 1 to e of log x squared dx. So let's try this. Integral from 1 to e of log x squared dx. That's the problem, right? Yes. So maybe first of all, to simplify this, you want to do u substitution, right? So if u is equals to x squared, if you make that substitution, you will get u to the power 1 by 2 is equals to x, right? And then you can differentiate both sides to get the differential element. So if you do that, you will get half u to the power minus half du using the power rule is equals to dx, right? Now we can substitute dx as this element, and also we can make other substitutions. So if x is square root of u and u is x square, in this case these limits are in the world of x, right? So if you want to change to the world of u, what you will do is just square them. So this goes from 1 to e square, log of x square is u, and dx is 1 by 2 u to the power minus 1 by 2 du, right? Now I can take this out. Half of integral from 1 to e square u to the power minus 1 by 2 log u du. But guys, do you find this helpful? I don't think this one will be more helpful than what we had initially, right? Because actually we could have just done integration by parts to this one rather than making the use substitution. That would have been more helpful. Because now from this one, it's been more complicated. So let's try that. I'm just going to erase this one. Okay, so if I use integration by parts with 1 as the b, this will be u, and then integral of b will be just x minus integral from 1 to e, derivative of log x square is just 1 by x squared times 2x, right? And the integral of 1 will be x dx. So yeah, it looks like this one is more helpful, right? So x log of x square minus, oh, over here I could have just taken 2 in front, and then integral of log x is just a standard integral. I forgot that. Okay, anyways, it's fine now. 1 to e, now this is just 2 dx, right? Now we can easily do it. X log of x square minus 2x, and this goes from 1 to e, right? So if you substitute the values, this will be e log of e square minus 2e, and at 1 this will be 1 log 1 minus 2, right? Now log of e square is just 2, right? E times 2 minus 2e minus, this is now 0, log of 1 is 0 minus 2. So this is 2e minus 2e becomes 0, and minus of minus 2 is 2. So this should be the answer, right? We could have also done it in an alternative way, like we could have just taken x square in front. That would have been easier, because integral of log x is standard one, though log x integral is also done with integration by parts, but we know the formula, the integral of log x is x log x minus x. So we could have just used that from 1 to e. That would have been 2, e log e will be e times log e will be 1 minus e, minus that will be 0 minus 1, so that will again be 2 into 1, which is 2. This is the same answer. So we get this answer, and this is how it's done. Did you get the same answer like Hera? I think you got the same answer, right? I'm sorry if I pronounced your name wrong. Yeah, I think this is what you also get. But yeah, we also have the answer key, so there's no need to worry if we are right or wrong. Yeah, over here the answer is 2. Yeah, so are we able to like do this integral? This one is easy, I guess. How did you find this one? Jeff is saying that I do not know calculus. I think it's fun to learn, Jeff. Like you can learn calculus, the derivatives, integrals, limits, partial derivatives, Green's theorem, and also the special functions. There are a lot of cool things to learn, and also like Stokes theorem. Yeah. As you go higher, it becomes more and more interesting. Yeah, so I recommend you to learn at some time. Now next is integral from minus 9 to 9 of sine of cube root of x dx. Integral from minus 9 to 9 of sine of cube root of x dx. So like right now, like people are not responding. How I don't know how they are finding it. Maybe it should be good. Okay, now let's see how we deal this one. So immediately, if I see that the domain is symmetric, what I usually try to do is try to see if there is an odd or even function. If there is an odd or even function, because I know that if the domain is symmetric, in that case, the domain is symmetric, integral from minus a to a of an odd function is directly 0, right? Because the odd function is supposed to be symmetric about origin. So from minus a to a, both of this area will just be equal, right? And they will be negative of each other, so that's why they cancel out and area will be 0. And if the function is even, then we can just say that this is 2 times integral from 0 to a of even of x, even function, right? And this is because even function are symmetric about y-axis, so these two areas will just be equal, right? If it's from minus a to a, so we can say that this area is just twice of this area over here, that is 0 to a even of x dx, right? So yeah, we try to see that. And over here, this is definitely a symmetric domain, and this is also an odd function. Let me prove it to you. So if f of x is sine of cube root of minus cube root of x dx, the definition for odd function is that f of minus x would be minus f of x, right? You can clearly see that the y value over here for a and for minus a, the y values should be negative of each other, right? So yeah, the y value for f of x is just f of x. So if it's to be negative for minus x, definitely it has to be minus f of x, right? So you can see it from the graph itself. And so yeah, we have to prove this. So let's try to prove that. F of minus x, let's see what do we get. So, cube of minus x. Now we know that cube root of minus 1 is just minus 1. So this minus 1 times cube root of x. And you know the sign is odd, so the negative sign comes out. So this is minus sign of cube root x. We know that sign of cube root x is f of x, so minus f of x. We proved that f of minus x is negative of f of x, therefore f of x is an odd function. And if f of x is an odd function, definitely the integral in symmetric domain is going to be 0. So that it is. Okay, like are you guys able to like catch up with the solution? Let me know if you are not, so that I can explain it better. Because yeah, I can see that you guys are not responding. Like are you guys understanding it? I hope yes, right? This wasn't a too hard problem, just an odd function in a symmetric domain which evaluates to 0. I think we have to go to the next problem now. The next one is about there's a derivative of e to the power 1 plus x minus x square from 0 to infinity. Integral from 0 to infinity of dx of e to the power 1 plus x minus x square, e to the power 1 plus x minus x square, and then there's a dx. Integral from 0 to infinity of dx of e to the power 1 plus x minus x square dx. Now you might have known that if there's an integral of a like differential element of f of x, this will just be f of x plus a constant c, right? So we'll use that. So basically, yeah, though it's not technically good, but yeah, we can cancel the dx, right? And now it's just the integral of the differential element of 1 plus x minus x square. I just told that the difference, if there's differential element of f of x, it will just be the same function. So this will just be 1 plus x minus x square evaluated from 0 to infinity. Now how will we deal with this one? Now we will have limit x goes to infinity of e to the power 1 plus x minus x square minus 80. We can just directly substitute this, right? Now over here, notice that this x square will be bigger than 1 plus x, right? For big numbers, definitely x square is greater than x plus 1. So this will dominate. So the overall expression will be dominated by x square, right? And so this whole thing at infinity goes to negative infinity, because 1 plus there's plus infinity, but there's an infinity square which is way bigger, so the overall result will be minus infinity. This is just analogy, this is not any rigorous proof. So sometimes like though things here are intuitive easily, like, it may not always be the case. Yeah, so e to the power minus infinity will just be 0. Yeah, if you like, you can also try to prove this using some rigorous ways, but yeah, for now we're pretty sure that this will dominate. So this will go to e to the minus infinity, that will be 0. Minus over here, it will be e to the power 1. So the answer is minus e. You see that? Right? It's minus a. Yeah. Next one, square root of x plus square root of x plus square root of x goes on. Integral from 0 to 2. Okay. Integral from 0 to 2 of the square root of x square root of x. This one is a good problem. And like, who of you who are watching this right now, can guys please try this and also let me know the answer before I do it myself. Yeah, that can make it more interactive and yeah, helpful for you guys too. Okay. So first of all, I need to like find a finite function equivalent for this infinite series, right? So let me name this function as f of x first, or let's say y. Y is this function. This function is right. I'm writing it in the proper way, right? Yeah. So let me first say that this y is just square root of x plus square root of x plus square root of x plus square root of x and so on, right? And now we will try to find a function representation for this series. Now for that, what you can do is you can just first square both sides. You can just first of all square both sides, right? After you squared the both sides, you will get y square is x plus square root of x plus square root of x plus square root of x. Yeah. Now we will try to use the deceiving nature of infinite series. Notice that this again looks like y because both of them are going to infinity. Yeah, so there's surely no difference. Infinity minus 1 is again infinity, right? Infinity minus 1 is also infinite. So there's surely no difference. So again, this will be y square is equals to x plus y, right? Now, y square minus y minus x is equals to 0. Now we'll try to solve for y from this quadratic equation. We'll get y is equals to minus b. Over here, the a is 1, b is minus 1, c is minus x, right? So minus b plus or minus square root of b square minus 4ac divided by 2a. I know you know the, I guess you know the formula, right? The quadratic formula is minus b plus minus square root of b square minus 4ac by 2a. So y is 1 plus minus square root of, this is 1 plus 4x by 2. Now, which sign do we take? Positive or negative? Okay, so to answer this question, first of all, notice that this result over here was positive, right? So therefore, we need to have positive result. So for that, even if like x is really small or x is big, while the x is big, if this root this expression is big, definitely the negative sign will make it negative, right? So to avoid that, we will avoid the negative sign and just say that y is 1 plus square root of 1 plus 4x divided by 2. So once we get that expression for y, now this is what the infinite series would evaluate to, this infinite series over here. So this integral is now integral from 0 to 2, 1 plus square root of 1 plus 4x divided by 2 dx. Yeah, 1 plus square root of 1 plus 4x divided by 2. Now let's try to solve it. Now this is kind of an easier problem. Integral from 0 to 2, 1 by 2 plus square root of 1 plus 4x divided by 2 dx. Now we are going to integrate this, right? So first of all, it's 1 by 2 times x plus this is 1 by 2, again the constants come out. Now we'll use the power rule. So this will be 1 plus 4x to the power 3 by 2 by 3 by 2. The power was 1 by 2 initially, now it's 3 by 2. And we also have to divide by the coefficient of x, which is 4 over here, 1 by 4. And this goes from 0 to 2. So now this is half times 2 plus, now the 2 cancels out, 1/3 times 1 plus 4 into 2 to the power 3 by 2 times 1 by 4 minus 0 plus, this is just 1 by 12, right? Yeah. Now that is, this is just 1 and this is 9 to the power 3 by 2. That means 27 by 12 minus 1 by 12. Again, that is 1 plus 27 by 12. It again means 9 by 4, right? Minus 1 by 12. Now that will be 12 plus 27 minus 1, which is 39 minus 1 by 12, which is 38 by 12, which is 19 by 6. I think this is the answer. 19 by 6. Yeah, that's the answer. Are you guys able to keep up with me? I hope you guys are. Right, like those of you who are watching, like please let me know if there's anything to explain better. Yeah, I will try to do that. Okay. Now 5 number. Square root of x e to the power square root of x dx. So let's do that. Integral of square root of x e to the power square root of x dx. Right? This is it, right? Square root of x, yeah. Let's try to do this. I think the u substitution might be a good option for this one. So let's try to say that u is equals to square root of x, right? And then we get u square is equals to x. That means 2u du is equals to dx, right? Now let's solve it. Integral of this is u e to the power u and dx is 2u du. I think now it's quite simple actually. Now we can just use the integration by parts or DI method. DI method is just a generalization of integration by parts, not generalization, just equivalent of integration by parts. So what you do is you choose a function as u, another as b, right? And this you, like if you have to integrate u b, you just write it as u u and the integral of b. Now minus derivative of u, right? Integral of b, double integral of b now. Oh wait, is it double integral? Yeah. Oh wait, am I missing something? This will now be, yeah, double integral of b. I guess, yeah, I think that's the thing. Yeah. Now again, plus double derivative of u, the triple integral of b. You just go on like that. This is the DI method. So yeah, this is just generalization from integration by parts. Yeah, it works the same way actually. Now let's do that. So e to the power, let's keep u square as u square, and the integral of this is e to the power u itself, minus, now its derivative is 2u, integral is e to the power u itself, plus its derivative is just, the sign will keep on changing. Now its derivative is just 2 integral e to the power u. After that it will be derivative is 0, so all the terms will be 0, so no need to go beyond this. I think this is the answer. X e to the power root x minus 2 root x e to the power root x plus 2 e to the power root x. So this is the answer. So let's see if this is the answer or not. Okay, so let's take e to the root x common, 2 e to the power root x common, and then we will have x minus 2 root x plus 2, right? So let's see, e to the power root x, and then x minus 2 root x plus 2. Yeah, let me check if my sound is working well. Or not. Beyond this, I think this is the answer. X e to the power root x minus 2. Yeah, it's working well. E to the power root then x. Why aren't guys responding? Okay, yeah, fine. Anyways, fine. So yeah, we have done this, right? Now I think it's time to go to the next problem. Now this one is sine 2x cos 3x dx. You might have noticed that interestingly problems are pretty standard problems, right? They aren't too hard actually. But yeah, it's good for beginners to practice actually. Sine 2x cos 3x dx. Integral of sine 2x cos 3x dx. Now how do we solve this one? For this one, we will try to change the product to the sum, right? Now you might know that like sine like 2 sine A cos B. Formula for this one is sine A plus B. Oh wait, sine A plus B plus sine A minus B, right? Yeah, so let's do that. And also, if they have sine U plus sine B, the formula is 2 sine U plus B by 2 cos U minus B by 2, right? Yeah, so let's do this. Now this thing is, this will be 1 by 2 sine 5x plus sine minus x, right? And the integral and then dx. And this will be half of, this will be cos, the integral of sine is negative cos, right? Yeah, negative cos 5x by 5. Now plus this minus sign will come out again, since it changes to cos, again that will be plus x eventually. This will just be cos x over 1 plus c. So the answer is half of cos x minus cos 5x over 5 plus c, and this is the answer. Those of you, 3 of you who are watching, I think you have got the same answer, right? Half of cos x minus, oh wait, why is the, oh yeah, yeah, I think it's the same answer. It's just multiplied by 2. Yeah, cos, we can take a half common, and cos x minus cos 5x 5 is the same answer. Let's go to the next one. Modulus of 1 plus 2 sin x dx. This one is going to be an interesting problem, I guess. Integral from 0 to 2 pi modulus of 1 plus 2 sin x dx. So integration from 0 to 2 pi modulus of 1 plus 2 sin x dx. And just from 0 to 2 pi 1 plus 2 sin x dx, right? Okay, now first of all, let us try to see whether this quantity is positive or negative, so that we can deal with it in the same way, right? Now for 1 plus 2 sin x to be positive, 2 sin x should be greater than or equals to minus 1. So sin x should be greater than or equals to minus half, right? Now in the in our like 360-degree coordinate system up to from 0 to 2 pi, okay, so over here definitely sin x is positive, right? Sin x is greater than minus half, right? So there's no problem in this one. In second quadrant as well, from 180 to up to 30 degree, up to this point, this is pi minus pi by 6, that is pi by 6. But in this region it's positive, right? Because it's greater than minus half. And also over here up to 7 pi by 6, this is positive, right? Because it's greater than minus half, right? And over here this will be negative. Over here that will be negative, right? And again in this region that will be positive, right? And now for this one this will be negative, because at this point the sin x is less than negative half, right? So what we can do is, so I think what we can do is, okay, so let's try to integrate all of them one by one. I know that's going to be a hard task, but yeah, that's the only thing we can do right now, as per me, right? Okay, shall we try that? Yeah, I think we should do that. But like, I'm just thinking if we can explore the symmetry. Like, I mean, the sin x will just repeat itself, right, after a certain period, and so maybe we can use that. Do you guys think that the area over here and the area over here, they will be same? Yeah, basically if the like curve should go to the same height, this should be same, right? So first of all, this 1 plus 2 sine x, this sine x times 2 sine x is start from 0, but we have 1 about there. This starts from here, right? Now, now uh, this can be our pi, and if this is our 2 pi, in between them if we have, let's say, pi by 2 over here, uh, 3 pi by 2, the curve will go up like this and over here like this, right? And it will hit 0. It will hit 0. When does it hit 0? Hmm? Does it not hit 0 up to pi? Okay, immediately. I think I've done a mistake, because over here sign is still positive, so there's no problem actually. Only in this scenario it's negative. I'm sorry. Sign is positive over here. I was treating it like a cos, right? Yeah. Okay. There's no problem in this quadrant. Okay. Now over here up to this point, 5 pi by, up to this point 7 pi by 6, there's no problem, right? And actually this is supposed to now go like this. So this is um up to if this is -1, if you just like see the graph of 1 plus 2 sine x first, and this will go up to -1, right? Because at maximum this is -2 plus 1 is -1, so over here it will go up to -1 at 3 pi by 2, and then again at 2 pi this should be right back to 1. Yeah, right back to 1 over here, and it will still go up after this one. Again it still go up and down. Yeah. So now up to the 2 pi, so there's this area. Definitely these two areas should be equal, right? You can see that. Yeah. And also, what about this area? This area from, okay, these two areas, definitely these two areas are also symmetric, right? These two areas are symmetric. These two areas are symmetric, right? Now what I think I should be doing is, first of all, I would find this area from 0 to pi, and then I will find this area twice this area twice this, and now I will add these two and subtract these two. That should be my strategy, I guess. Okay, let's do that. First of all, let's find out area from 0 to pi, and we know that it's positive over there. So 0 to pi, 1 plus 2 sine x dx, and this is just x plus 2 times minus cos x from 0 to pi minus 2 times cos pi is -1 minus 0 minus 2, right? So this is pi plus 2 which is pi plus 4. Okay, we got that area. Now let's try to find area from pi to 7 pi by 6, right? So area from pi to 7 pi by 6 of, in this case this will be 1 plus sine 2x, it's 2 sine x itself, because it's still positive, right? Yeah. Now that area will be okay, x minus 2 cos x from pi to 7 pi by 6. It's 7 pi by 6, the 7 pi by 6 minus 2 times now 7 pi by 6. That will be how much? Okay, so basically we just need to find cos pi by 6, which is root 3 by 2. Now that's minus root 3 by 2, right? Minus root 3 by 2. At pi, this is pi minus cos pi is negative 1, right? Now that is basically 7 pi by 6 plus root 3 minus pi. This is plus 2, and again that's minus 2, right? Yeah. So now this is pi by 6 plus root 3 minus 2. Okay, got this person as well. Now let's find this person. Now let's find the other person. That area is basically, why isn't this getting erased by itself? It just happened earlier. Okay, now let's try it from other area. From 7 pi by 6 to 3 pi by 2. Yeah, 3 pi by 2. And this area of this, now notice that we have to take the modulus of this area, right? And yeah, for that we can just take minus 2 sine x minus 1 dx, or we can also like just first find the area and then make the area positive. Either way works, right? Now this is the integral will be 2 cos x minus x, right? From 7 pi by 6 to 3 pi by 2. At 3 pi by 2, cos thing is negative, is 0. 0 minus 3 pi by 2. At 7 pi by 6, that will be minus root 3 by 2. So this is minus root 3 minus 7 pi by 6. So that is minus 3 pi by 2 plus root 3 plus 7 pi by 6. And that is now equal to at 6 over here. So this is minus 9 pi plus 7 pi plus root 3. So that is minus 2 pi by 6 plus root 3, right? Which is root 3 minus pi by 3. Okay, so we have got these three values, right? Now the only thing we need to do is to find the net integral. First of all, keep that thing over there, pi by 4. Now there are two such things, right? So plus 2 into this one, pi by 6 plus root 3 minus 2, and yeah, again this two of them, 2 into root 3 minus pi by 3. So let's evaluate that. Now this will be pi by 4 plus pi by 3 plus 2 root 3 minus 4 plus 2 root 3 minus 2 pi by 3, which is, this cancel out, and pi plus pi by 3 is 4 pi by 3 minus 2 pi by 3 is just 2 pi by 3, and that is plus 4 root 3. 2 pi by 3 plus 4 root 3. I think that's the answer. Let's see. Whoa, that's the answer, and our hard work paid off. 2 pi by 3 plus 4 root 3. Now let's go to the next one. The next one is x times 1 minus x to the power 2014 dx, right? Let's go to the next one. 8 number. 8 number is integral of x times 1 minus x to the power 2014 dx, right? Okay, let's do this. 2014 dx. Now let's see how to solve this integral. Now what we can basically do is, over here in the like binomial expression there is a power, right? And like if this power was in the monomial, it would have been a lot easier to deal. So we'll try to make that change, right? Or I think even if it's like this, it will be easier to deal using integration by parts. We can directly use that as well. We don't need to like make this substitution as well. That will also be perfectly fine. So let's do that. So now if it's integration by parts, this has u and this has b, x 1 minus x to the power 2015 by 2015 times minus 1, because the coefficient of x is minus 1, and then negative of integral of the derivative of x is just 1. Its integral is minus 2015 by 2015, and since there's coefficient of x minus 1, we have to make this plus dx. This is minus x, 1 minus x to the power 2015 divided by 2015 plus 1 minus x to the power 2016 divided by 2015 into 2016, and also a coefficient of minus 1 because x has coefficient of minus 1. Now this one is minus x, 1 minus x to the power 2015 by 2015 minus 1 minus x to the power 2016 by 2015 into 2016, and that should be our answer. Do you want to check the answer? Of course we should, because we never know. Okay, now I think the answer is slightly different, so let's try to see if we can get that answer, right? Now for that, in the answer, like there's really no negative x, yeah. So what we can do is, let's try to take 1 minus x to the power 2015 by 2015 common with a negative sign. If we do that, am I right about the signs? Am I correct about the signs? So let me check it first. Okay. Yeah, that one is right. And then, yeah, that's also right. I think I'm right about the signs though. Okay. Now this is minus x. Sorry, because minus already common. X plus 1 by 2016. Why don't the answer match? The answer is slightly different, right? On place to the power 2016. How do? But let me try to use a different approach so that I would get the same answer, right? Because yeah, I definitely want to make you guys sure that the answer is right. So let me try to use a different approach so that we get the same answer as it's there. Integral of x, 1 minus x to the power 2014. Now another approach could be to just let u as 1 minus x, so that you get x as 1 minus u and you get dx as negative of du. Even if you do that, you get x as 1 minus u. This is u to the power 2014 and dx is minus du, right? Now this will be u to the power 2015 minus u to the power 2014 du, right? So that will be u to the power 2016 by 2016 minus u to the power 2015 by 2015 plus c. Now u is 1 minus x. So 1 minus x to the power 2016 by 2016 minus 1 minus x to the power 2015 by 2015 plus c. This is exactly the answer that's given over here, right? Yeah. Okay, so we can proceed ahead now. Integral of arc sin as x. That's our next question. Our next question is integral of arc sin as x. Integral of arc sin as x dx. I'm really happy to see that the two of the viewers have been consistent and they are still there. Thank you so much for watching. Yeah, I hope you guys are enjoying the solutions. Yeah. Now for this one, we can basically use integration by parts again. So we can use say one as u and this as v, right? And so if you make that like assumption, I mean make that like consideration, we get first of all u. Sorry, yeah. I think I mean it's opposite. Let's make u this as u and this as v. So we get first of all u, and then integral of b, which is integral of 1 is just x, minus in the integral of, you know the formula, right? B times integral of u minus derivative of b times integral of u. Yeah. So now derivative of b is derivative of u is, we know that derivative of arc sine x is just square 1 by square root of 1 plus x square, right? And the integral of 1 is just x, yeah, so dx. Now this is x times arc sine x minus, now how do we solve this? I'll just introduce a 2x thing over here. There's a reason for that. Now over here, if I let this as u, the 2x dx will just be du, right? And it will just become 1 by 2 root u. And we know the integral of 1 by 2 root u is just root u. So yeah, that's the reason I'm doing this. So we have x arc sine x minus root of 1 plus x square plus c, and that is the answer. So let's check it. X arc sine x minus square root of 1 plus x plus c. Yeah, that's right. Let's go to the next question, 10 number. Integral from minus 1 to 0 of x square by x minus 1. Okay, integral from minus 1 to 0 x square by x minus 1 dx. Now how will you solve this problem? So yeah, I think for this one, it's just better if you just divide numerator by denominator and just try to break it into multiple rational functions, because that just simplifies our problem. Let's try to do that. Integral from minus 1 to 0, I can set it as x square minus 1 plus 1. I'm doing this so that I can just isolate two expressions, x square minus 1 by x minus 1, right, plus 1 by x minus 1 dx. And notice that, like if let's say if this integral was from like minus 2 to 0, over here in the middle at minus 1, okay, no, I think if this integral was from 0 to 2, the in middle at 1, this should have been indeterminate, right? But I don't think a point discontinuity would have matter anyway. But leave that's not our concern. Yeah, let's try to solve this one. Now this from minus 1 to 0, x plus 1 by x minus 1 dx, right? Since this function is just continuous at the given domain. Now what you can do after this is you can integrate it, x square by 2 plus x plus ln of x minus 1. Notice that in ln, this is basically the modulus will be there, because both the derivative of ln x is also like 1 by x, ln of minus x is also like basically 1 by minus x times minus 1, right? This will again just be 1 by x. So the integral of 1 by x will just be ln of the both things. So we have to give modulus of x. Yeah, I guess you know that, right? Ln of modulus of x minus 1. And this is from minus 1 to 0, right? At 0, this is 0 plus ln of 1. I mean the minus 1, but modulus will just be 1, minus 1 by 2 minus 1 plus ln of modulus of minus 2, right? And this will be 0 minus half plus 1 minus ln of 2, and that will be half minus ln of 2. Is that the answer? Yeah, half minus ln of 2. I hope you got the solution, right? This was just like I broke one rational expression into two rational expression, right? And after that, just the integration as normal thing. Let's go to the next question now. Next question is basically integral of arc tan x dx. You find that even without like sufficient preparation, I'm doing these problems easily, right? Yeah. Also because it's the qualifying round, the later on like the regular, those are a bit hard though not those regular and yeah. But yeah, the regular, the qualification is not that hard, and it's actually fun for the learners like who are just learning it for the first time. And yeah, if you are one of those, hope you are enjoying this, right? Next is uh, integral of x arctan x dx. Integral of x arctan x dx, right? So let's do this. And I just hope that you are enjoying. And if you have any problems, yeah, the comment section is open for you guys. Let me know. I'll try to address if there's problem with understanding anything. Yeah. Okay. So let's solve this. Again, we'll try to use the integration by parts. We'll assume this as u, this as b, and then we'll use the formula for ub, that it's u integral of bu minus integral of derivative of u integral of b. Yeah. Let's do that. First of all, we will have arc tan x, right? Integral of x will just be x square by 2, right? Minus integral of derivative of arc tan x is 1 by 1 plus x square, right? Is it? No, I don't think so. I don't think so. This is for that. Just yeah, it is 1 plus x square. I'm sorry. This is arc tan. No, this is not arc tan. It's just arc tan, right? If it was arc, yeah, I think this is, yeah. If it was arc tan x, this would have been 1 minus x square. If we had to cot, then x minus 1. Yeah, okay, good. Yeah. Now, derivative of arc tan x is just 1 minus x square, and the integral of x is just x square by 2 dx, right? Now this is arc tan of x times x square by 2 minus 1 by 2 x square by 1 plus x square dx, right? And now arc tan x times x square by 2 minus half of, now I can introduce a plus 1 and minus 1 over here, right? And so that will be arc tan of x times x square by 2 minus half of, this will just be 1 minus 1 by 1 plus x square dx, right? This is arc tan of x times x square by 2 minus x by 2 plus half of tan inverse x plus c. And that's the answer. Let's check it. Arc tan of x times x square by 2 minus x by 2 plus half arc tan x. Yeah, that's the answer. Let's go to next one. Dx by x square minus 15x minus 2014. Okay, let's go to the next one. Integral of dx by x square and then minus 15x minus 2014 minus 15x minus 2014. So this one is a like regular high school problem, and yeah, let's do this. Okay, like since I have already seen the answer key, I know that it will be perfectly factorizable. So yeah, I will try to go with that approach. So how to factorize this expression? So let me use like the normal high school way. We will try to first find the factors. So 2 times 1007, right? Now next, what do I choose? If I choose 7, that will be 7 times 1 is 7. That's what, no, that won't work. Will 11, 13, will 13 work? No, that won't work. Will 17 work? 85, 15, 15, 57, I don't think 17 will divide 57 though. No, 19. Yeah, I think 19 works. Okay, 19 times 5 is 95. Now 57. 19 times 3 is 57, right? Okay, yeah, so 19 works. Now 53. for 53. Okay, now I think I have already seen the answer. Basically, minus 15 can be written as minus 38 plus 53, right? And yeah, their product is minus 2014 and their sum is 15, right? Yeah, okay, let's do that. Now dx divided by okay, x square minus 38x. Okay, sorry, this should have been plus 38 and then minus 53. I'm sorry, plus 38x minus 53x minus 2014, right? And that is dx divided by x plus 38 minus 53 x plus 38, right? Again, that will be dx divided by x plus 38 x minus 53. Now we can use the partial fraction. So what we will do is we will introduce like x plus 38 minus x minus 53 over here in numerator, so that we can break this to partial fractions. But please note that with the numerator we are adding 38 plus 53 by ourselves, right? The x cancels out. This term have been like introduced by ourselves, so we have to like divide by that as well. This thing is 91, right? So 1 over 91. Yeah, that makes sense, right? Yeah, so now 1 by 91, 1 by x minus 53 minus 1 by x plus 38 dx. So now that is 1 over 91, and this is minus ln of x minus 53 minus ln of x plus 38. What, like, did it really go as per expected? Our answer was supposed to be in fraction, right? 53 and 38, but it seems like they are in product right now. Yeah. Oh, wait, how there's no minus because no, the x doesn't have a negative coefficient. Okay, wait, how did you arrive at x plus 38 minus x minus 53 in the numerator? Okay, so yeah, how did I arrive at that? So I basically introduced that by myself, so that like if I make this fraction like I mean if I break this into individual fractions, there will be cancellations, right? Now if I break this into individual fractions, there's definitely going to be cancellations, right? And the benefit of the cancellations is that if this cancels out, our like integral will be simplified, because now there are two different rational functions and I can integrate them one by one, right? So that's why I did that. And the reason I could do that was initially over here it's just 1, right? And later on, after I introduce this, definitely over there the x and the x are going to cancel out, right? If I like open this up, the x are going to cancel out, and 38 plus 53 is just 91. And also I'm introducing 1 by 91 in front, so that's just cancels the 91 in numerator. So if that cancellation happens, it's again the same thing as it was previously. So that's why I did that. Oh, okay, got it. Yeah, I'm really happy that you got it. So now, okay. So basically, if I integrate this integral of like 1 by x minus a, that is just ln of x minus a. Yeah, we use that formula. Also, if it's x plus a, it's the same, right? Because the constants won't really matter. Ln of x plus a. Yeah, so now we know that ln of a multiplicative inverse 91 and expanding it by adding your x minus x into the equation. I think that's what I've done. Yeah, it's the inverse 91 and then expanding it by adding. Yeah, exactly. Now we can just use the property that ln of a minus ln of b is just ln of a by b. So this will be 1 by 91 times ln of x minus 53 divided by x plus 38. First done, and then that we get first done, and then yeah, exactly, you are getting it right. First of all, like you can do 91 by 91 and then write 91 then x minus x. Yeah, exactly. Yeah, you are like doing it step by step, and that's really good. So yeah, this is our answer, right? Now I think you have understood the steps after that line. I mean, after making this like rational fractions, breaking into two rational fractions, you have understood the other steps as well, right? Let me know if you have problem with the steps after that. I can just wait for a few time, because yeah, if anyone is watching, uh, he can definitely skip this. The wait. Sakshit, like, can you confirm if like the steps after that are good to go? Exactly. I think the steps after that are good to go, right? Yeah. Anyways, you can ask me if you have. Like, I'll just come back and I can explain it to you. Yeah, but for now, I think we are good to go. So let's go to the next problem. The next one is. Next one seems a bit. Oh, there's Asim Paudel as well. Yeah, Asim. Hi, nice to see you. And yeah, Asim, I hope you are in solving the problems. Let me know if you want anything, any help, any doubts, or if you want to like share your answer, the way you solve, right? Let's go to the next one. We have integral of e to the power x and then log of 1 plus x square minus 2 times 1 plus x arctan x. This really seems like a complex problem, but I'm pretty sure that the MIT Integration B team would not give a complex problem in the selection round. So let's see this. E to the power x log of 1 plus x square minus 2 1 plus x arctan x. Okay. Integral of e to the power x log of 1 plus x square minus 2 times 1 plus x arctan of x dx, right? To the power x, and then just try to solve this one. Now, like, how do we actually go on solving this problem? I think a good approach would be. So, what I think would be a good approach? Shall we just go on doing integration by parts for this one? Would that be a good idea? What do you think? Yeah, I think we should just go ahead with doing integration by parts for this one and see if we can connect it with the other one, right? But the problem is this e to the power x can create a problem for us if we are doing integration by parts. How should we go? Do you guys want to suggest something? Let me know if you want to suggest something. So I think that we should just go on solving. There are 11 viewers, and yeah, guys, if you want to suggest something, please let me know. I can go with suggestion, and like we can try that and see if it works or not, right? Oh, let me just try this. Let me just first try to go with integration by first for the first one. So it will just be log of 1 plus x square, and the integral of e to the power x is just e to the power x, right? Minus integral of, now derivative of log x plus x 1 plus x square is 1 by 1 plus x square times 2x, and integral of e to the power x is just e to the power x, right? And we have minus integral of e to the power x times 2 1 plus x and arctan x dx. We have all this thing later on, right? Now this is e to the power x log of 1 plus x square minus, this is 2x by 1 plus x square e to the power x minus integral of e to the power x 2 times 1 plus x arctan x dx. How do I go on solving this problem now? This is something to think of. I think what I can now do is, since here's an arctan x over here, what I can try to do is manipulate this integral somehow, because I know that they are not going to give us hard problem. It's gonna be just simple problem. So yeah, now this is what I will try to do is, let this just be 2x e to the power x times 1 by 1 plus x square. I will try to integrate this one and differentiate this one so that we get the same thing. I'm not sure if it will work, but yeah, we can give it a try, right? It's just about trying and doing and trying and doing, and yeah, sometime at some point we will definitely be right. Yeah, e to the power x times log 1 plus x square minus, now if I just write this first, 2x e to the power x, and now integral of other one, which is arctan x, the minus will become plus sign. The integral of derivative of this thing is 2 times x e to the power x plus e to the power x, so that this is x plus 1 e to the power x. And guys, see, we are there, minus e to the power x times 2 times 1 plus x arctan x dx. So see, our thought process was exactly right. And now this does cancel out, and we have e to the power x log of 1 plus x square minus 2x e to the power x arctan x plus c, and this is the answer, right? Guys, I think this was a good one, right? I mean, yeah, it was kind of a nice idea. E to the power, let's check the answer. The answer is e to the power x, and then in the bracket there's log 1 plus x square minus 2x arctan x. So that's the answer. The next one is arc sin x square dx. Integral of arc sin x square dx. Now let's try to solve this problem. Asim, are you there? Like, are you? Can you like suggest me your way to solve this one? Like, are you enjoying the video or anything? If you want to chat, please do. That would make the video interactive. Yeah. Okay. Now let's try to solve this one. Of course, I know that we are going to use integration by parts with this as u and 1 as b, right? So this will be arc sin x square as this u, and the integral of 1 is just x minus integral of 2 times arc sin x, and then by chain rule, derivative of arc sin x is just square root of 1 plus x square, and then x dx, right? And this will be x arc sin x square minus 2 times integral of, I can actually put this 2 over here, arc sin x times 2x by square root of 1 plus x square dx. Again, we can integrate this with this as u and this as b, right? This will be x arc sin x square minus u, and the integral of that thing is basically I can introduce a 2 and 2 over here. If this is just, let's say, m, sorry, okay, now if I do that, what I mean to say is if this thing over here is m, this thing over here is dm, right? And now integral of 1 by 2 root m is just root m, right? So we will just have 2 times square root of m, which is 1 plus x square, right? There's 2 over here, which is over here, and then we will have plus integral of the derivative of that is 1 by square root of 1 plus x square, and the integral over here there is 2 square root of 1 plus x square dx. This cancels out, which gives us x arc sine x square minus 2 arc sine x square root of 1 plus x square plus 2x plus c. So this should be the answer. Let us see if this is correct or not. X arc. Did I do any sign error? Oh yeah, I think I did do, I don't know, wait. It doesn't look like I did one. I'm sorry actually. Over here this should have been, oh, this eraser is too big. Okay, it should have been negative sign. I think I need to erase this one because the whole thing is messed up now. Yeah, I think I will erase this one. Yeah, I'll do it again. I'm sorry for that. I'm sorry for that, guys. Okay, so this is 2. Let's do it again. 2 arc sine x times 1 by square root of 1 minus x square times x dx, right? Now what I can do is I can write this as plus now. There's a reason for that, because I'm going to make it 2x over here, right? Then square root of 1 minus x square dx. Okay, make that plus, this will also plus plus. Now after that what I can do is I'll introduce a 2 and 2 over here, but for the same reason that I told earlier, and this will just be arc sine x times 2 times square root of 1 minus x square, right? I had explained this earlier. And then again there are going to be minus sign, and this will be 1 by square root of 1 minus x square times, this will just be 2 times square root of 1 minus x square dx. This cancels out. This will be arc sine x times 2 square root of 1 minus x square minus 2x plus c. Now this is going to be the answer. I'm sorry for the error previously. Let's take the answer. Correct. Let's go to next problem. Next problem is square root of x square minus 1 by x dx. Square root of x square minus 1 by x dx. Next problem. Next problem is integral of square root of x square minus 1 by x dx. Okay, now I think the trig substitution will be helpful in this case. Yeah, let us substitute that x is sec theta, because if x is sec theta, over here sec square theta minus 1 will just be tan square theta. So that's the reason I'm doing this. So this will just be tan theta by sec theta, and dx will be sec theta tan theta d theta, right? If x is sec theta, dx will be sec x tan x dx. Okay, sec theta tan theta d theta. This cancels out. We will have integral of tan square theta d theta, which will now be integral of sec square theta minus 1 d theta, and that will now be tan theta minus theta plus c. Now since x is sec theta, we know that sec square theta minus tan square theta is equals to 1. So x square minus tan square theta is equals to 1. X square minus 1 is equals to tan square theta, and tan theta is square root of x square minus 1. Therefore, the square root of x square minus 1 theta is just sec inverse x plus c. I think this is the answer. Square root of x square minus 1. Explain that. Now we know that if, let's say, y is sec inverse x, I can write this as sec of y is equals to x. And now we know that square root of 1 plus sec square y will be square root of 1 plus x square, right? And we also know that, oh, I'm sorry, square root of sec square y minus 1. Sec square y minus 1 will be x square minus 1, right? Now we know that sec square theta minus 1 is just tan square theta. So this will now be tan y is equals to square root of x square minus 1. So y is tan inverse of square root of x square minus 1. So therefore, since y is all sec inverse x, we can say that sec inverse x is tan inverse of square root of x square minus 1, right? Therefore, I can also write this as square root of x square minus 1 minus tan inverse of square root of x square minus 1 plus c. There's really no reason for doing this, just to complicate stuff, but because the answer here was in that form. Good, next problem. Integral of x sec square for x dx. Let's do this one. Guys, you might have noticed that the regular season is just too easy, right? 16, I mean the qualifying rounds are too easy actually, right? Integral of x sec square for x dx. Integral of x sec square for x dx. X sec square for x dx. Yeah. Now, yeah, you guys can give a try before seeing the solution. That can be helpful for you. Yeah. And if you are not able to do, yeah, you can definitely check the solution over here in the video. So let's see how we can solve this one. We will again use the popular integration by parts. We will assume this as u. We will just let this as u and the other as b. If we do that, we will now have u integral of b is just tan 4x by 4 minus integral of derivative of x is just 1, integral of sec square for x is just tan 4x by 4 times dx, right? Now this is x by 4 tan 4x minus, that will just be 1 by 4 integral of tan x is, what's the integral of tan x? Ln of sec x. So this is ln of sec 4x, again divide by the coefficient of x, which is 4, plus c. So that is x by 4 tan 4x minus 1 by 16 ln of sec 4x plus c, and that is the answer. X by 4 tan x. Again, now we know that like sec is just inverse of cos, so we know that ln of 1 by x is just minus ln of x. Using this, I can write this as x by 4 tan 4x plus 1 by 16 ln of cos 4x plus c, right? X by 4 tan 4x plus 1 by 16 log cos 4x plus c. Yeah, that's good. Let's go to the next one. Whew, the next one seems to be complicated, but I don't really think that they will again give a complicated problem. Yeah, it's just an os. Okay, so let's try to solve this one. 2 divided by 6 minus 11x plus 6x square minus x cube. Next is integral of 2 divided by 6 minus 11x plus 6x square minus x cube dx, right? Integral of 2 by 6 minus 11x plus 6x square minus x cube dx. Okay. I think the only good approach that I have in my mind is to somehow factorize this expression. Now to factorize, first of all, we have to find the roots, right? The numbers that make this expression 0. Let's try to find that. What about let's say 2? Obviously 1 doesn't work. Let's try 2. 6 minus 22 plus 24 minus 8. Oh, it works. 30 minus 30. That's 0. So that means if f of 2 is 0, x minus 2 is a factor, right? Now to find remaining factors, I can either do polynomial division or also I can do synthetic division. Okay, for synthetic division, I will just write the 0 of this like factor, which is 2, right? And then I will just write remaining, just write the dividend with just the coefficients. So x cube has minus 1 coefficient, x square has 6, x has minus 11, and then 6. Notice that if there is like any term missing, we need to write 0 for them. First of all, just bring this down, minus 1, and just multiply the divisor in this number and write it over here. This is minus 2, right? Again, add them. 4 times 2 is 8. Add them. Minus 3 times 2 is minus 6. Add them. 0. If you get 0 at last, that means it's perfectly divisible. And yeah, that should happen because obviously x minus 2 was a factor, so that will happen, right? Now so this tells us that if I divide 6 minus 11x plus 6x square minus x cubed by x minus 2, the other factor will be minus x square plus 4x minus 3. Okay, I hope you got this one. Now if you know this one, now let's try to integrate it. Integral of we have 2 as it is, 2 dx divided by x minus 2 minus x square plus 4x minus 3. Now what do I do? Can I further break x minus x square plus 4x? Okay, first of all, let me write it as negative 2 dx divided by x minus 2 x square minus 4x plus 3. Can I do anything over here? Is there any? Yeah, I think that I can do minus 3 minus 1, right? Product is 3. Yeah, let's do that. Minus 2 dx by x minus 2 x square minus 3x minus x plus 3, because sum is negative 4, product is positive 3. That is integral of negative 2 dx by x minus 2. Now this is x I can take common, so x minus 3 minus 1 x minus 3, right? And this is minus 2 dx divided by x minus 2 and then x minus 3 x minus 1. Now I think that we are in right track. We are in right track now. So now this is negative 2 dx by x minus 1 x minus 2 x minus 3, right? Now what will you do? At this point, what we can do is we can try to break this into partial fractions. Now for that, I have a good rule called cover-up rule. In that, what we will do is, let's say if I want to break this into partial fractions, I do know that this will be a by x minus 1 plus b by x minus 2 plus c by x minus 3. Now how to find this a, b, c, right? Now what we can do is, to find the coefficient in the numerator of x minus 1, just cover this x minus 1 for some time. I didn't mean to erase that. Okay, yeah. And then substitute its root in the expression that we get after covering it up. We get 1 by 1 minus 2, 1 minus 3, right? Which is 1 by minus 1 into minus 2, which is half, right? Yeah. So we will have half over here. Now remove this cover. Okay, we will have half over here. Now cover this one. For x minus 2, cover this one. Okay, up to that, substitute 2. 1 by 2 minus 1, 2 minus 3, which is negative 1, right? So we'll have negative 1 over here. Yeah. So again, remove that now. Yeah, we will have minus 1 over here. Similarly, if we do for C, that will be 1 by 2 times negative 1. So that means negative 1 by 2. Right? Oh, wait, no, just positive 1 by 2. 1 by 2 times 1 it will be. Yeah, 1 by positive 1 by 2. Yeah, I think that's right. That's right. Okay. Now, if you know, now this was a good way actually to do this, right? Now we are good to go. So this integral will be, if you multiply by negative 2, this will be negative 1 over x minus 1, positive 2 over x minus 2, negative 1 over x minus 3 dx, right? After this, what we can do is, we know that we can integrate this by using normal log formulas, right? This will just be log of x plus a plus c. Yeah, so let's do that. This will be minus log of x minus 1 plus 2 log of x minus 2 minus log of x minus 3. And now I can write this as log of the positive terms in numerator. So we will have x minus 2 square divided by x minus 1, x minus 2. And this should be our answer with a plus c. Right? So let's take the answer. Let's take the answer. The answer over here is, okay, so let me also multiply that. Okay, over here is, I can write this as 2 times log x minus 2, right? And because the power goes to front, minus, if you multiply them, this is x square minus 4x plus 3, right? Plus c. So let's check it. 2 log x minus 2 log, it's 2 minus x over here, but since we definitely have modulus over here in log, that won't really matter. Okay, 2. Let's go to the next one. Let's go to 18 number now. We are almost at the end of solving all the problems of the qualifying round of MIT integration B 2014, and that too without any preparation. It's going fine till now, and I hope that we will also not have problem at the end. Hope we will be able to go through this easily. But yeah, this next problem seems to be somehow complicated, right? There's a floor function over here, but let's see. Hope that's not too bad. Integral from 0 to 1 of 1 by this g function of 1 minus log 2 of 1 minus x. Integral from 0 to 1 by g function of 1 minus log 2 of 1 minus log 2 of 1 minus x dx, 1 minus x dx, right? Is this it? Integral from 0 to 1 by g of 1 minus log 2 of 1 minus x dx. Yeah, that it is. Let's try to solve this. Now, this one is a pretty interesting problem. Like, if those of you, 5 of you who are watching, you might want to invite your friends to solve this problem, or you can also give it a try. Do you want to give it a try first before I solve this? Before I try to solve this? Guys, do you want to give it a try before I try to solve this? Yeah? Let me know. Okay, can you guys let me know of your approach? Those of you, 5 of you who are watching, can you guys let me know of your approach? Like, how would you deal with this one? Huh? I would actually love to hear from you, like what would be your idea? The 7 of you who are watching, can you please give me any idea how will you proceed? I would love to hear it from you. Yeah. Do you want to share anything? Like, you have any idea like that you want me to use? Or if not, I can like go with my own like intuition or own idea. But yeah, I would love to hear it from you too. Maybe I think I should go on my own. Yeah, let me do it. I think what I would do is I would just first sorry, I would first try to let this as u. I would first try to let this thing as u, right? So that it would be simplified. Yeah. Now if I let that as u, 1 minus log 2 of 1 minus x. Uh, Now we need to find the differential element, right? Now that will be log 2 of 1 minus x is equals to 1 minus u. 1 minus x is equals to the power 1 minus u. 1 minus u to the power 1 minus u is equals to x. And dx would have been... Am I just overcomplicating? No, I guess. Dx is just... now this is... you know that this is just 1 minus 2 times 2 to the power minus u, right? So okay, so this will be the derivative of 1 will be 0 minus 2 times its derivative will be 2 to the power minus u times ln of u, 2 times the coefficient of u is minus 1. I guess you know that derivative a to the power x is a to the power x times ln of a, right? So I'm doing the same thing over here, but also there's a minus 1 from chain rule because u has negative 1. So this is our du, right? So dx is 2 times 2 to the power minus u ln 2 du. Yeah. Okay. Now okay, now if we change the the limits, 8x equals to 0, we will have u as 1 minus log 2 of 1 minus 0 is just 1. 1 minus this is again log 2 of 1 is just 0, so that will be 1, right? Yeah. And that x equals to what is this? 1. Oh, u is equals to 1 minus log 2 of 1 minus 1. This is 1 minus log 2 of 0. Log 2 of 0 is just minus infinity. So 1 minus infinity, which is plus infinity, right? So this goes from 1 to infinity now. That's cool actually. 1 to infinity, and over here we will have 1 by gif of u, and dx is 2 times 2 to the power minus u ln 2 du. I can definitely take this 2 ln 2 outside, and now this will be integral from 1 to infinity 2 to the power minus u by gif of u du. Now whenever there's a gif involved in an integral, what we will try to basically do is, we know that gif is kind of a discrete function, right? Like from 1 to 2, the gif will evaluate to 1. From 2 to 3, the gif will evaluate to 2. Gif of u evaluates to 2. From 3 to 4, it evaluates to 3, right? So what we can basically do is, we can break this integral into different parts. Let's say from 1 to 2, where the gif will evaluate to just 1, plus 2 to 3, where the gif will just evaluate to 2, and like go on in the same way up to infinity. So what I'm basically trying to do is, I'm trying to write this integral as sum from I is equals to 1 to infinity, an integral from I to I plus 1. You see there? Yeah. I to I plus 1 of 2 to the power minus u by, this thing will just be I du. Okay. Now let's continue in the next page. 2 ln 2 sum from I equals to 1 to infinity, integral from I to I plus 1 2 to the power minus u by I du, right? Now next thing that we can do is, since the world of integral is on u, I can take this 1 by I outside, right? Because that's just constant. So that will be 2 ln of 2, and then sum from I equals to 1 to infinity 1 by I integral from I to I plus 1 or 2 to the power minus u du, right? Next thing is 2 ln 2 sum from I equals to 1 to infinity 1 by I. This will just be, integral will just be 2 to the power minus u times ln of, oh sorry, divided by ln of 2 times minus 1, right? Yeah, and this is from I to I plus 1. Okay, now I can take these constants outside, so this will be minus 2 ln 2 by ln 2, and then we will have sum from I is equals to 1 to infinity 2 to the power minus u by, or 2 to the power, if I evaluate this, minus I minus 1 minus 2 to the power minus I by I du, right? Now this will be minus 2 times, I don't know where I'm going actually, but I just hope that I would be fine. I is equals to 1 to infinity, this is just 1 by 2 times 1 by 2 to the power I by I minus 1 by 2 to the power I by I. Okay, I can sense that this sum n is equals to 1 to infinity of x to the power n by n, this is just minus ln of 1 minus x, right? So let's use that. Minus 2 1 by 2 minus ln of 1 minus half, right? And then minus, this is again minus ln of 1 minus half, right? So this is minus 2 minus half times ln of half plus ln of half. Yeah, so this is now minus 2 times, this is half ln of 2 minus ln of 2, which is minus ln of 2 plus 2 ln of 2. Oh, the answer is so good. Answer is just ln of 2, right? Bro is really OP in integrals. Okay. Oh, thanks for that compliment. But yeah, did you also get the solution? How we like broke the integral in terms of sums, using the fact that we can break this z function into individual parts, right? Yeah, awesome. Okay, yeah, I'm just happy that you got this, right? Now after we broke this into like multiple, like part by part integrals, then it wasn't too hard. Then after that, we just had this like very easy integral of a to the power x, right? And we used formula for that. After that, we just had two sums, and the sums were in the form of the log function, and we used that and we got the answer. Yeah, so this is ln2. Let's take the answer. The answer is pretty good actually. Yeah, and that's right. Let's go to the 19th number. Let's go to 19th number, and it feels really happy when the viewers are enjoying the integrals, right? So integral from 0 to 1 by root 3 square root of x plus square root of x square plus 1 dx. Integral from 0 to 1 by root 3 square root of x plus square root of x square plus 1 dx. Now that bro said I'm OP, but I don't have any idea how to deal with this one. So let's see how we can deal with this integral. Guys, do you have any idea? Let me know if you have any idea how to proceed ahead with this one. I think I would love to do the substitution actually. Trig substitution, because this number does look like some trig identities to me, and I think that the roots will get simplified. Yeah, exactly. I'm also thinking, yeah. as like you have suggested inside, I think I should go with trig substitution, because yeah, let's try that. And now for this one, the trig substitution that will be helpful is x is tan theta, right? Also because this is the like tan 30, that's also a clue. Also that simplifies with the tan function, right? Because we know that tan square theta plus 1 is sec square theta, right? So yeah, that will be helpful. So let's try that and see if we can make any progress. So if we do that, this will just be integral from 0 to tan 30 is pi by 6. Now this is tan theta plus, now this is sec theta, right? And over here we will have dx as sec square theta d theta. Now what do we do? Now for this one, I think that integration by parts can be helpful. If I just name this as, let's say, I as integral of root under tan theta plus sec theta, I think that integration by parts can be helpful. Let's see. We know that if I use integration by parts, this will just be I times sec theta plus tan theta. The integral of sec square theta is tan theta minus integral of, now this is just, if I take the derivative, 1 by 2 root sec theta plus tan theta, and then there will be sec square theta plus sec theta tan theta, right, times the integral of sec square theta is just tan theta, right, d theta. Now I will have integral of square root of sec theta plus tan theta times tan theta minus half of integral of, now if I can take sec theta common, sec theta tan theta, and then this is again sec theta plus tan theta, right, sec theta plus tan theta divided by the square root of sec theta plus tan theta. I don't know where I'm going, but I do think I can like change something over here. That's cooking. Yeah, I can change something though. Let me see if it works or not. Tan theta minus, okay, I'm in the right track, so I just differentiated and then I just added that, and the integral of sec square is just tan. I'm in the right track, right? Okay, now this is minus half times, this is now square root of sec theta plus tan theta, right, times sec theta tan theta d theta. Okay, is that good? Is it good? Oh, here's a plus sign that I missed. Yeah, I think it's good. It's good. Okay, now let's go ahead. Again, let's try to use integration by parts. I think that this is going to be reversed back. So I is equals to tan theta times square root of sec theta plus tan theta minus half of the square root of, sorry, minus half of, now its integral will be square root of sec theta plus tan theta, and its integral is just sec theta, right? After that we will have plus half, right, because the negative sign will be there, and the integral of, we will have again 1 by 2 root sec theta plus tan theta, and then its derivative will be sec theta tan theta plus sec square theta. After that we had this thing, right? This integral is just sec theta d theta. Yeah, so we have now I as, I think you guys can see where we are going, right? Sec theta plus tan theta minus half of sec theta square root of sec theta plus tan theta plus, now this is 1 by 4th of, the square root. Now there will just be sec theta common. So where we now we will have, basically, first of all, I also step by step, tan theta plus sec theta times sec square theta divided by square root of sec theta plus tan theta d theta. Okay, now I can this will just be cancelled out, so we get we get okay, square root of sec theta plus tan theta. Now notice that this is the original integral, so we have I is equals to tan theta times square root of sec theta plus tan theta minus half of sec theta times square root of sec theta plus tan theta plus 1 by 4 times, this is the original integral, right? Yeah. So now we have I minus 1 by 4 times I is equals to tan theta square root of sec theta plus tan theta and minus half of sec theta times square root of sec theta plus tan theta, right? Now this is just 3 by 4 I is equals to tan, I can take sec theta plus tan theta, the root common, so we will have 1 minus half, right? And now I will be, oh wait, no, not 1 minus half, that will just be tan theta minus half sec theta, right? And now after that it will be 4 by 3 times square root of sec theta plus tan theta times tan theta minus half of sec theta. So that's the answer. But we need to evaluate this from 0 to pi by 6. From 0 to pi by 6. At pi by 6, this will just be square root of sec pi by 6 is cos pi by 6 is root 3 by 2. So sec pi by 6 is 2 by root 3 plus tan pi by 6 is 1 by root 3 times tan pi by 6 is 1 by root 3 minus 1 by 2 times 2 by root 3 minus at 0, this is 4 by 3, sec 0 is 1 plus tan 0 is 0 times tan 0 is 0 minus sec 0 is 1, right? But here notice that this 2 cancels out, so 1 by 3 minus 1 by root 3 will just be 0. So 0 minus, this is 4 by 3 times negative half, which is 4 by 3 times positive half, which is 2 by 3, and that's the answer. This is also a good problem. Yeah, it's right. But I also think that since this is a MIT integration, be regular the regular season problem, or because it's a qualifying round, there should be an easier approach too, right? This was also not that hard, but still this was long, right? And like the whole competition is just too short. Actually, it doesn't have a lot of time to do all this stuff. Yeah, anyways, we got the answer, and this was actually pretty good stuff where we can use integration by parts. Yeah, you also think so, right? Because the MIT integration be like won't have that long time. There should be an alternative approach. And yeah, if I do find, let's try to comment in this video like our approach for this problem, and that will be helpful for other viewers. Yeah. Okay. Now for this one, we have solved it. The answer, we got the correct answer. And yeah, this is actually also a like good app. I mean the good way to solve some problems where while using integration by parts, the integral will repeat itself, and that helps us to solve problem. Okay, so this is a good way as well. Let's go to the next problem. And this is the last problem, guys. So yeah, finally we have how much time has it been? okay, it's around 2 hours that I've been solving the problems of Hamilton integration B, and yeah, we're almost at the end. Like in the actual round, I don't think the timing will be more than 1 hour. I think it's just 20 minutes or so. I think 1 minute per integral. So yeah, actually, I have taken a lot of time, but yeah, I just hope that you have understood the solution anyway. So 0 to 5 pi by 2 dx by 2 plus cos x. 0 to 5 pi by 2 dx by. This is actually a pretty standard integral. I just think that many of you would have done this one in your high school, where we just break this as the half angle formula, like cos square x by 2 minus sin square x by 2, right? And we break this as 2 times 1 and break 1 as sin square x by 2 plus cos square x by 2. This is a pretty standard approach actually, so let's use this. Integral from 0 to 5 pi by 2 dx by 2 times sin square x by 2 plus cos square x by 2 plus cos x is cos square x by 2 minus sin square x by 2, right? Now this one is integral from 0 to 5 pi by 2 dx by, now this is 3 cos square x by 2 plus sin square x by 2, right? Now if we divide both numerator and denominator by sin square x by 2, no, I mean cos square x by 2, that will be sec square x by 2 dx by 3 plus tan square x by 2, right? Now if you make a substitution that y is tan x by 2, dy will just be sec square x by 2 times 1 by 2 dx. So 2 dy will just be sec square x by 2 dx, right? Now this thing over here, we know it's just dy. So we can write it as now, okay, now y is tan x by 2. So tan 0 by 2 is just 0 and tan 5 pi by 4. Tan of 5 pi by 4, this is just tan of pi plus pi by 4. We know that tan of pi plus theta is just tan theta, because this lies in third quadrant where tan is positive, right? So this is just tan pi by 4, which is just 1. 0 to 1. Now that's just 2 dy, 3 plus y square. Now this is 2 times 1 by root 3 tan inverse y by root 3. This is because integral of like dx by a square plus x square is just 1 by a tan inverse x by a. Using this formula we got this. Now this is from 0 to 1. So 2 by root 3. Tan inverse 1 by root 3 is pi by 6 minus tan inverse 0 is 0. So this is pi by 3 root 3. This was a standard integral, so I did a bit fast, and I do hope that you were able to catch up with it, right? Just break this into formulas and then divide by cos square x by 2 and then use the u substitution and you get the answer. Let's take the answer. Oh, so what did I mess up? Guys, where did I mess up? Because the answer is basically 7 root 3 pi by 9, which means the answer is basically 7 pi by 3 root 3. Where do you think I messed up, huh, guys? Let me check it once more. Is this with the fact that this limit is not in the principal value? Is that what's causing the problem? Because let's try to see it through the graph actually, and then it will be more obvious, right? Okay, then the graph will be, since this is 2 plus cos x, okay, it 0, that's 1 by 3. So let's draw, okay, basically over here the cos x the cos x. I think the reason we have the problem over here is I know that we got this one as a result of this one was actually tan of 5 pi by 4, right? This was actually a tan of 5 pi by 4, right? Now this 5 pi by 4 we actually got this from third quadrant, right? Now when I inverse this, I again need to take the value of third quadrant, because that's basically has to do that this is basically a repeating function, right? I mean the values are basically repeating. So over here this limit like corresponds with like this original x value. So when we are going back, we again have to consider the value from third quadrant. So in third quadrant the tan inverse 1 by root 3 will just be uh, this is pi plus pi by 6, 7 pi by 6, right? Yeah, and now that works. Yeah guys, don't please don't make this mistake ever again. Yeah, I think you have learned it. Also I have learned it. Like I have faced this problem several times, and I just realized that okay, now this is just 7 pi by 3 to 3. Now it's right. Okay, we got one we got this question wrong at first. I'm sorry for that. Okay, now I think, but you have now realized that the the if you are making like changes to these like trigonometric functions, so we need to get back to from where we had taken the value. Basically, the originally if we are changing the values from the pi's to numbers, again when we are getting back to the values, try to go with that initial same value. So that's what caused the problem. So 7 pi by 3 root 3. Yeah, now it's right. So yeah, now we're finally done with all the problems of MIT Integration B qualifying exam 2014. And yeah, if any of you are having any integral B competitions, like there's one in Nepal, I think there are a few in India, maybe they are in China, or anyway, like in any part of the world. I think this does give you a good practice, right? Especially if you are in high school or like maybe just finished the high school. And yeah, I hope this is helpful. If it's helpful, do share with your friends too. Like it can be helpful for them as well, right? So yeah, the only goal of this channel is to make sure that there are enough learning resources for everyone around the world. So yeah, I'm just trying for that. Yeah, that's the goal, and I really appreciate if you are like helping with that goal. Like if yeah, I basically think you know what I mean. Yeah. So that's it for today's video. We will meet in the next video with the problems from MIT Integration B 2015. And like if you want to know where do I get these problems from, there is basically a website in the MIT's official website. You can just go to math.mit.edu and just you can search for integration B problems, and there are all the problems from 2010 to 2024. So next time I will look forward to seeing you in the solution of 2015. And yeah, hope we will have a great time in the next session too. Thanks for watching. I look forward to seeing you in the upcoming session. Now how do I